If you turn on your PRAC, you'll come at this screen. We just push escape. We're going to change. We're going to go to the wizard. Suction and condensing. We're going to go degrees and bar. Reciprocating compressor. In this case, on the VBox, we have one compressor. Scrolling down, when we're looking at this for number of alarms per compressor, we can come on this sheet and we can see here we have a high pressure, low pressure, INT, oil fault, an inverter fault per compressor. So that's 5 faults per compressor. So we can come in here and we can change that to 4 only. So we'll have to group together some. Let's have a look. Oops. Hopefully the inverter one we can put separately. So put 4, go down. We have a speed modulating device, the inverter, and the compressor equal size. We're only going to have it as 100% because we don't have an inverter. And unloading, we'll just say neutral zone for now. I'll pretend that the set point is 3.5 bar, and we start off with a big differential and we can work that down smaller later. We'll see how the control goes. No other suction lines. We don't run 2 separate PRACs. This is asking if you want a second PRAC for the condenser. Number of fans. We're running an inverter fan, 2 inverter fans, but we actually just say 1 fan because we're only, if we have a look on the wiring diagram here, we can see condenser fan fault. We just have 1 single fault coming back for the condenser fan as an input, and also we're only sending 1 signal out to a fan, 1 0 to 10 volt signal. So we say 1 fan even though there's 2. And for the condenser, we're also sending a 0 to 10 volts out. Pressure, condenser can be proportional. Let's just say the condensing again. I'll pretend that this is 4FRA. I'm not sure what you've got. 4FRA, we'll set that up at about 17.5 with maybe a 2.5 bar differential. If you want 3FRA, give me a call. We'll do it different. No other lines. Yep, wizard can do its thing. 1 board's necessary. Most likely you'll look in and have 1 PRAC. Press enter. Sorry, this takes a few moments, but silence. Success. Press enter. Come to this screen. First of all, we push the menu button here. The password is 1, 2, 3, 4. Enter. Now, it's pretty much the easiest way to do this is start with compressors and then we come back to inputs and outputs later. Regulation, we're going to regulate by pressure. We can set up a minimum, and it can be a good idea just to make sure you put some sort of a minimum in there and maximum, just so some idiots don't go in later and do something silly, but it doesn't really matter. Set point, let's leave that for now. Now, a neutral zone means that if we imagine this line here, 1 bar is nothing's going to happen in that 1 bar. 0.7 activation line, so for 0.7 bar above, and our set point's going to be in the middle. So we're going to have 3.5 bar minus half a bar plus half a bar. Nothing's going to happen. When it gets to 4 bar, from 4 bar to 4.7, so activating differential, across that 0.7 is going to determine how fast the compressor ramps up. And from 3 down to 2.3, this deactivation 0.7 is going to work out how aggressively it slows down. If we have trouble where the compressor is pumping down too quickly or ramping up too quickly or too slowly, we can either extend or tighten these activation and deactivation zones. Enforced power off is like a pump down. When we get, we'll say yes. When we get down to, example, 0.5 bar, turn the compressor off. Ideally set this above your LP. Imagine or treat your LP like a safety. We really want the system to run and stop on the PRAC. So again, power load to 100% minimum. So like I said before, if our set point was 3.5 and a neutral of 1 bar, at 4 bar to 4.7, it's going to increase. If the pressure's 4.1, it's going to take 30 seconds. It's going to very slowly increase because we're not far from the set point. But if the pressure's 4.7, it's going to increase very quickly. So I just like to extend these out a little bit. The truth is, nothing needs to happen too quickly. We're not talking about an operating theatre. We're not talking about something extremely critical. Just blow these out. Big times so that the compressor is behaving slowly. On loading. On unloading, if we behave too slowly, we're just going to pump down all the time and turn off. So unloading, conversely, I'll probably say as quick as 5 seconds if we're getting really far from the set point. And otherwise we can be, maybe as slow as 45 seconds. So it'll slowly start to turn the compressor off unless we get really far from the set point, and then it'll happen quickly. We don't have two things, and that's it. Next one, we go to alarms. We can set a suction pressure alarm. Again, we're going to have to set this lower than our LP force off. Or sorry, this is high suction pressure alarm. You're better off setting this quite high, otherwise you're going to get nuisance alarms. Maybe if the system balances off. So set that quite high. And again, the differential. Low alarm, set that quite low. You might set that, just above 0. And again, the differential to reset. Inverter warning, yes. Turn off. Switch off the compressor. Yes. Reset. Make that automatic. Put a couple of second delay on that one because the inverter will take care of itself anyway. Superheat alarm is only if we're looking at temperature sensing, and I don't think we are. 4. Okay, alarm 1. Have a quick look at your drawing. You said alarm 1. 1, 2, 3, 4. So here, high pressure, high, low, motor, oil. Ready? So alarm 1. It's not an overload. It's a high pressure. Alarm 1. Activate delay. Just always put a couple of seconds delay in. It just stops you getting a nuisance alarm. Reset manually or automatic. Won't really matter anyway because it's a HP. There. Alarm 2. It's not that. Alarm 2 is low pressure. Same thing. Have a couple of second delay. Otherwise you can get some nuisance alarms sometimes. Probably have that automatically resetting. Alarm 3 was an overload, I think. Please. Overload, yeah. Oops. Again, just put a couple of seconds in there so you don't get any nuisance tripping. And last but not least, last but not least is oil. And oil, you might even put longer if you want. Again, you can see you can even delay the alarm longer on startup if you think you're going to get cold starts. It's good to set to automatic because some of our oil alarms, you can't quite see how Martin's done it here. Some of our oil alarms are off the oil fill and they can automatic reset. And that is it for our alarms. We're back to the start. Configuration, 1 compressor, it's enabled, 404. Min time on, you're going to have to turn the minimum time on down, again, in case it goes to pump down. Might turn on, try to pump down. If you don't have that set quite low, it's just going to try to pump its ass out and it's going to suck. Minimum time off, time between starts. Yep, great. Direct, we're not equalizing pressures with a solenoid. We don't really have rotation. Don't worry about load up and load down. Inverter, min hertz, max hertz, we can set those up. We can set here, again, the minimum time on. We're going to drop this down, sorry, because it's an inverter compressor. This only really matters if you've got multiple compressors, like one compressor's 10 horsepower and the other compressor's 20 horsepower. You'd have to set it up here so that the PRAC understands when it's turning the next compressor on as bigger. We're not doing that, so it doesn't matter. That's it. And advanced. Again, 0 to 10 volts is what we're sending to the inverter. Let's string out this rising time. We want that inverter to ramp up nice and slow, give our expansion valve and everything time to, our EC fans time to react. Let's slow it down a little bit faster so that we don't pump down and turn off for no reason. Enable this yes, which allows the inverter to adjust speed in the neutral zone. This can be used, so but I don't recommend it. This is in case of probe failure, what we can do. Another one that can be used here is pump down. If we change this pump down to yes, what it will do, it will try to let the rack pump down to 1.5. So even though we get to the lower pressure setting, it won't turn off straight away. It'll try to pump down. So it is a valuable setting, that one. That is all, and we are done in advanced. Condensers even faster. Regulation, pressure. You can set your min-maxes, put your set point. Fans only work when at least one compressor is running. Look, I find that advantage to put yes, otherwise the fans can sometimes just keep running on a hot day for no reason. Integral time is just like a damper. The truth is, you don't really need it. Sometimes people like putting it in there. There's different ways here that we can offset the fan. We're not going to do any of those. Alarms, high pressure. This is a high pressure alarm. Oops. No. Low condensing pressure alarm. Again, cold mornings. If you don't turn this down, you sometimes can get some nuisance trips on some really cold mornings because your system pressure drops. So just drop it down a bit. Common fans overload. Yes, we do have a common fans overload, and we can put a delay on that so it doesn't get nuisance trips again. That is it. Config one fan, because we're only giving one signal. And that is it. And advanced. This is an interesting one, so just pay attention here. EC fans, 3 volts actually equals minimum. So when I give 3 volts to an EC fan, here we go, there we go, 3 volts will equal 5% fan speed. So we're going to come down here, we're going to change this, 3 volts, oh, sorry, 10%, whoops. 3 volts is 10%, 10 volts is 100%. That is what an EC fan is, so just be careful of that one. It is different. Rising time, falling time. Once again, if you find that the fan is hunting, sometimes if we're over condensing, you'll get a problem with expansion valves not feeding and stuff, so sometimes you might want the fan to slow down a little faster than it speeds up. If you find you get super hot weather and it's not speeding up fast enough, you might have to decrease that as well. But again, we have set up our compressor to ramp up over 45 seconds, so we shouldn't have an issue. These are all noise-related times of the days. If we want to do different things, do the fan to run. If the probe fails, well, no. That is advanced for the fans. Do make sure that you come into settings and set your clock. Make sure that your adjustment here, your clock is set up. If you don't go in and set the time and the date, then your alarms, times and dates won't have a meaning. All right, now that we've done that, it's good to come up to now our inputs and outputs. So we get inputs and outputs, status, digital inputs. Now we've said we're not doing, ignore the common low pressure unless you've got an additional low pressure switch, which we don't, and common high. Inverter warning. So again, look here, inverter warning is going to this one, which sorry, where is it? ID6. Come here, click ID6. It's showing it normally open, but it's hard to say. Unless you look through the whole wiring diagram and work out whether this is normally open or normally closed, you're going to have to potentially change that to normally closed, and it will say not active. So if you see that there's no alarm on your inverter, then you're going to have the status is closed and the logic is normally closed, and then that's going to be the way it is. Go to the next one, alarm 1. Once again, come in here, alarm 1, 1, 2, 3, 4 for the alarms. So alarm 1, come on, be nice. Alarm 1, position 1. Alarm 2, position 2. Same thing for all of these. You're going to have to just have a look on the wiring diagram whether the logic is open or closed. Have a look if the alarm is active, and then it should obviously be showing here as not active if the actual alarm is not active on your panel. Alarm 4, number 4. Only other thing that we did have was this fan alarm here, and that is 7. So we'll have a common fan inverter, common overload is coming into 7. Martin has something going in here at 8. Standby function. I'm not too sure what he's doing there. I think it has something to do with liquid return. If you have any issues with things starting, let me know. Was there another page? That looks to be it on the PRAC inputs. So basically that's all your inputs done now. Analog inputs is your pressure probes. So you're going to come in again on this document. Oops. You were here. So you've got your suction probe going into U1, your condenser probe U2. Where are we now? So come here, U1. Make sure this matches 4 to 20. You've got to look at the probe. Probably your suction probe is going to be like a 0 to 10 bar, and it's got to match. If it doesn't match, then everything means nothing. So you match this to whatever the probe is on the suction line of the compressor. Suction temperature you probably don't have. Condenser pressure probe, U2. Once again, it's probably a 0 to 30. So just make sure that what is on the probe, the type of probe, this is the little silver bullet probes, and the values are matching. Next we go to digital outputs. If we have a look on here, digital outputs was the first page. Where is it? Here. So we had NO1 for compressor 1, 1, 7, and 8. 8, no liquid return. I'll have to have a look at that. Digital outputs, compressor 1, only open. Nothing going to fans. Global alarm was 7. So whenever we get alarms, energizers 7. And again, Martin's no liquid return. I'll have to look at what he's got set up for that. That is it. And last but not least, analog outputs. The inverter is going out to O1. The inverter fan is going to O2. Let's just quickly, we'll go into compressors. I think in advanced, Martin has got this, used this no liquid return feature. Where is it? Here we go. Enable anti-liquid return value. Yes. And then we don't put a delay in it. So if we come back in inputs and outputs, oops, status, digital inputs, let's have a look at a good level. I think it's not going to be here, it's going to be in that, it's in the digital outputs. Sorry, Martin does some funny things. Here we go, anti-liquid return. So this one here, no liquid return, he had NO8. So I need to put this in 8. That's what we normally open. Okay, so again, this normally open all the pages, just got to check. I believe that what Martin's doing, I just can't see it, you haven't given me the whole wiring diagram. Here, this no liquid return, I think it only allows your expansion valves to open when a compressor is available. That's what this no liquid return signal is doing. Okay, so now we've basically set up everything. Clear any alarms that you have. Like I've got alarms, obviously no probes. You're going to have the same when you first turn it on. Hold this down, clear your alarms. Now what you're going to want to do before you start, come into inputs and outputs and manual management. Go into your analog outputs. What you can do here, you can enable, to test that your EC fans are working, you can enable your discharge for 10 minutes. Come down, force your fan, example to, I don't know, whatever, 15%. See that your fan's spinning nicely. Come in again. Increase your fan to, I don't know, whatever, 70%, press enter, and your fan should roar its ass off, both fans running. Check. If this is working, you know that you have your EC fans correct. If not, get your multimeter out, check that the 10 volts is going to your EC fans, and adjust. After you've finished, you must come here in manual management and disable this once you know you've got your EC fans working. Now that you know that EC fans are working, you've got no alarm showing, you've tested your normally opens and normally closes, you can even flick your pressure switches and make sure that your pressure switches are triggering alarms. Now that you're happy to start live, all your valves are open, your gas is in there, you can come in to this on-off, push enter and turn it to on. This will change the signal here, and the compressor, if we come out to the main screen, if you push enter, it'll start showing if compressor is running or not. And here, compressor 1, 0%, and there'll be a countdown timer here showing when your compressor is going to start. Of course, assuming you have no alarms showing. And that is basically everything that's needed to get the P-rack set up and running, matching with this wiring diagram. Cheers. Good luck.